Righto, so we've been running this for 3 days now, and actually this is day 4, sorry, so after day 3 it starts to siphon itself out. So it siphons itself out from the cathode side through the anode side, and you can see here it's leaking out onto this tray, which is why I put the tray there in the first place. But yeah, it's all chlorine solution. So, and around the back here, I think it's just around here somewhere, it seems to be leaking out of the lid joint. It's not doing it all the time either, it's only every now and then. So it's odd because there's no leaks coming from under there or from over here. No, it's dry there, so it's it's pretty odd. So I need to empty it, and then I'll have to go back to doing it again, and I guess we can record the days to see if after day 4 we have the same issue, which I suspect we will. Day 1 and 2 we don't. I have a feeling it's got something to do with this being saturated with chlorine gas, and once the gas can't escape, it's pushing its fluid out or through the seals here. Yeah, anyway, that's where it goes. So I've just removed the plugs, so the cathode and the anode side, and you can see here that there is a massive buildup of what appears to be rust. So somehow this fluid, the ions from the iron, when it's overflowing, are traveling back up and around the actual electrode itself. I'm getting a bit closer, it's a bit hard to see in here. I'll take it out, there we go. See the rust build up around it. And I have a piece of the indicator paper here. And if we put it in here, it should turn darker. Yep. So that's exactly the reaction I was looking for. Put that there. So it's number 1. That one right there would be the closest to it, or number 2, but so highly acidic. So definitely leakage from the anode side, which is frustrating, but it's an interesting process because it's like an electro siphon, and it probably shows the importance of venting. The only reason I frown upon venting here is because we are inside a garden shed and I'd very likely gas myself out. I don't like to open the containers in here and stuff like that as well. We take them outside in the open air to open them. So this solution here, I'm going to keep it. I'll collect it and take it out. So when we get it out into the sun here, you can actually see the difference and how much fluid has actually been transferred over into this one here, through as if it's an electro siphon, or there must be a capillary action or something like that. I don't exactly know what the name of it is, but it is an interesting process, that's for sure. The reason it is a bit of a pain is because I'm trying to make sodium hydroxide is what I'm doing. So I've got this container here and I'll siphon the remainder of that out, plus the sodium carbonate on the bottom as well. We'll transfer that into that one there, and we'll also transfer all the chlorine that's been manufactured here back down into this bucket here. Have a look at this, this is pretty interesting. Crack this open, and look at those icicles on there. So it's whether it's just pure hydroxide that's formed straight on the electrode or sodium carbonate. I guess we'd have to give it a test. Normally the product closest to the electrode is more likely to be sodium hydroxide, which is exactly what I've been chasing. I've never seen that before, but I've never run one dry before either. So obviously this has just gotten down to the point where the electrode is no longer touching the water. And as soon as that happened, it stopped siphoning. Pretty cool. Well, I think it's cool anyway, but I'm gonna try and siphon that now using this hose here. Siphon it out into there. And what I'll do is I'll draw it out and we'll try and vacuum the sodium carbonate straight off the bottom. Like this. It's a bit harder when there's not much fluid to work with, but it still works. Close that up. We'll have to clean the electrode as well. Do the chlorine side while we're here as well. You see the chlorine side there. Now this one's a bit more risky, of course, because this whole unit's going to be gasified. What I might do, we'll see if we can zoom in a bit closer and we'll adjust this camera here. Something like that. The camera will probably fall over in a breeze, but we'll give it a crack. Get this lid off here. Obviously there's a very strong smell of chlorine gas. That's it. Now it is May the 1st, 2025, and I started this process on the 18th of April. So it's almost been 2 weeks, so 13 days since I first started to process seawater using electrolysis. As you can see in some of these clips, I started off pretty rudimentary, of course. It was a very basic setup using some AAA batteries, but I soon discovered electrode gap was too small to actually utilize the toy setup. So that's just the AAA batteries. If it had been in a single jar and it wasn't a H cell, then I would have gotten better results. But because there's such a gap between the electrodes and the bridge between the two cells is so large, I had to increase the voltage to get the correct ampage. And by doing that, I've been successful in manufacturing sodium hydroxide and chlorine and hypochlorite as well, I'm guessing, because of the mixture of the sodium and the chlorine mixtures. But you can see here, I have a whole jar just full, waiting to be utilized. I do have fairly big plans for this kind of stuff as well. I've been reading up on oxygen candles that they use in submarines and stuff like that, and I reckon it'd be pretty interesting to go down that pathway to see what was involved in actually turning this into perchlorates or chlorates, which are oxygen heavy, and when actually burnt will release, from what I understand, copious amounts of oxygen. There is a little test to do once I process it. Now the way you process chlorine solution into perchlorates and chlorates is to actually just leave it out in a glass jar in the sun. As you can see up here, the UV rays from the sun itself will actually process it itself into your perchlorates and chlorates. And once it's been done, we can actually evaporate it. And then from what I understand, the perchlorates and the chlorates will actually be in a solution before the salts are present. So You basically dehydrate it down, and then just before the final salts start to crystallize out, you pour off the liquid and you should have your perchlorates. There is a test to do as well to confirm whether it is perchlorates, and that is to, I believe, add a tinder to it, and if it ignites, then of course you've got yourself perchlorates. But that process I'm yet to fully learn yet, so bear with me with that one. But you can see here as well, we've got a bit of fluid here as well, and it's a bit dirty because of the electrode. It's actually broken down. But I believe that this process using this cell is, one of the more important processes that anyone should learn. Learn it and try and fully understand it. And the only way you learn this kind of stuff is by actually having a go at it, and research, heaps of research, because what I've got here is basically a little chemical factory in my backyard where I can manufacture sodium hydroxide for soap manufacturing and chlorine for the manufacturing of perchlorates or chlorates, or even as a cleaning solution or a sanitizer, and you can even treat water with it if it's treated the correct way, so hypochlorates and stuff like that as well. So anyway, that's where we're at this stage. We've got quite a copious amount of fluid there, and we do have quite a bit of the sodium here as well. And we'll go get a strip of litmus paper and we'll give it a test just to see what the comparisons are. I'm a bit dubious about opening this one though. I reckon it's probably highly gasified. So the first test we'll do is with the solution in here. Again, it'll be similar to the earlier test that we've done. So it's very evident that it is chlorine. It's a strong chlorine smell coming off it. Very similar to the process you find in saltwater pools. The chlorinator, it's basically exactly what it is. Yep, so you can see that that's had an immediate response. So it's very acidic, as you can see there on the chart. It's a 1 or a 2. I imagine it's more likely be the 1. And we'll do a test on this other solution here. And this one will be a bit different actually, because the very bottom of the tank itself, so the bottom of the container itself, you can see there's an actual layer on the bottom, and I believe that is more concentrated, not just with sodium carbonate but sodium hydroxide as well. But if we put this in, you should see a response here as well. This needs to be dehydrated, of course, and reduced, but yeah, you can see it's gone green, so we're talking an 8 or a 9 maybe on that scale. So that definitely needs to be more concentrated. I would have liked to actually process it further, but the leaching problem that I'm getting, where the fluid is traveling from the cathode into the anode and then through the top here and out the edges. So if we go around here, yeah, you can see that there, that mark, that's where it's leaking from. So it's actually bleeding out and either flowing down from the top here and over the ring, which is taking the iron with it, which is why it's so corroded. If you have a look at the two differences here, it's extremely corroded, the iron ring here, and this one, it's not tarnished at all. It's looking like new. This one, on the other hand, is being oxidized, being rusted extremely quickly. And you can see, yeah, the rust that's gathered around the top of the electrode there as well. So it's running out and down into the tray that I've got underneath it. Yeah, so this is the tray with the fluid on it, and I'm going to tip it straight into this bucket. Again, we tested that earlier, it definitely is acidic. And that's it for the time being. won't put that lid on there though, we'll put the white lid back on. And I think the next step now will be to either start considering to process this by leaving it in the sun and perhaps reducing this. I actually found a couple of coconuts that I want to process for the fats. So I was down near the water the other day and I found these laying in a park. They're not huge, they're only small. I don't need a lot though to do a test. I'll break it open, crack the nut open, and we'll scoop out the flesh of the coconut and we'll fry it up, extract the oils off it, and then we can use the sodium hydroxide down in here to attempt to make a small bar of soap. And I know it is possible because I've done it before. It's all basic science, but it's still extremely interesting considering I'm actually just using a bucket of seawater I got from the ocean and some stuff I found laying around on the beach to make bars of soap and chlorine products for basically nothing. Literally, like, that there would have cost me maybe $10 as a setup, and the glass jar was a couple of bucks. The bucket was free. The solar panel, on the other hand, that's a bit more of a cost, and that is what powers my whole process. So you can see it's charging there, runs back inside, back to a battery here. From the battery, I've wired it up with a piece of scrap I found, back to the solar cell, which sits up here. So usually that sits up here. You can see the corrosion that's happening here as well. So this is obviously why I put that green lid down, that tray, is to try and reduce the amount of erosion that's happening. It's traveling around the back here and then vanishing down there to the concrete, I can guess, but it's probably softening all the concrete as we speak. But by putting that tray in, it's reduced that hazard from happening anyway, so we should be all good. Have a look at that electrode. That has just been worn down to a nub. See if we can get some sunlight on it. There we go. Totally corroded. Righto, so we're going to set this back up. Now, setting that back up is just a matter, it's like setting a trap. Basically, we just turn it back around. We can identify what side was the anode and what side was cathode by having a look at the oxidation states of the iron rings. Extremely rusty, so this one here is the anode and this side here is the cathode. I need to clean that up as well, but we'll go get some seawater and we'll put in it. In fact, I've solved this problem here, and I'm guessing most of you's probably picked it up far before I did if you've been watching this video. The rust that's coming from here is definitely coming from here. So it's oxidizing, and that's what's resulting in the rust settling on the electrode there. Mystery solved. One mystery solved. Biggest mystery to solve is this capillary action that's happening after 2 or 3 days, where it starts to siphon out my cathode into the anode and out onto my tray. I want to solve it, and I believe I can probably fix it by drilling a hole in the top of this and letting the gas out. But my concern is that if I start bleeding the gas from the actual anode reactor itself, I'm going to end up with a porous solution of chlorine in the fluid itself, which is not something I want. But it could also be an indication that the fluid is actually indeed saturated and unable to hold any more gas, which is why it's leading to a capillary action. And yeah, it might be time after 2 days, for example. That might be the sign that the system has run as much of a process as it can, given the dimensions of the reactors themselves. And that's what I'm guessing, but again, I could be wrong. And feel free to correct me in the comments. That is insane. Of course, we'll do one more test. So you can see the color change in that. It's going purple. A bit hard to see here. Maybe that would be a bit better. There we go, look at that. This is some award-winning photography right here. But yeah, that is concentrated sodium hydroxide. It's a thing of beauty and a thing of burny too. You got to be careful not to get it on your skin. And yes, I'm not wearing gloves, but I've handled this plenty of times before in the past. It's quite safe if you know what you're doing. In fact, I encourage people to experiment with science. I know this whole video will probably get throttled in regards to views because of my views of what science is. Science is setting something up in your backyard and playing around and learning these processes. These processes shouldn't be protected by health and safety. You know, I'm not saying that health and safety isn't important either. It's extremely important. But as a child, you learn from your mistakes and you just make sure that you put in the procedures in place to learn from your mistakes, not to repeat them. So yeah, even with this here, yes, it's very caustic. You just got to be careful not to get too much of it on your skin. If you do get it on your skin, wash it off. Don't get it in your eyes. Avoid taste testing that. You don't want to be taste testing that. Yeah, there's a few things that you want to avoid with it, of course. But I do believe that everyone should learn the process of manufacturing this, especially from seawater like I'm doing at the moment. It's a free resource and it shouldn't be hidden or protected from the public's view because of health and safety concerns. That's just my thoughts anyway. What you can do is you can actually, I've got a hole on the top of this, so I'll scrape it off into the jar itself, into this hydroxide container, like so. You see it's extremely caustic, but it's not caustic to the carbon electrode like the chlorine is. The chlorine is extremely caustic to it, as you've seen in that previous shot I did of the anode electrode. So we might put that down there. See that there. It's over here. And we'll give it a wash off. It's best to try and keep your electrodes as clean as possible, of course. The more surface area it has to work with, the better off it's going to be, the process. And there's no better way to clean it than actually using the solution you've created. It's actually got a soapy smell to it too, the entire solution. And feel free to put in a heap of comments about how dumb I am for not wearing gloves doing this. The more comments, the merrier. It doesn't matter if they're positive or negative, just have at it. What's more concerning is my heavy breathing. It's years of poor diet choices. Trust me. Righto, so we're gonna try and rebuild this now. You can see there's still a bit of fluid in there too, look at that. Up in there. Anyway, so what I might be able to do actually is we'll put it down, we'll close him up, we'll see if we can get it to drain out in there. Yep, she's draining out. Open that up. Righto, that's gonna do it. Go ahead now, we'll put this back. That It was more of a struggle than what it should have been. Now, when you're wiring this back up, you don't want to be holding this with salty hands and then pick up that clamp with salty hands, because you will become part of the circuit. And the shock you'll get is nothing spectacular. We're not on an inverter or anything. It's all 12 volt and the ampage is fairly consistent with it, but it's only very low ampage. From what I can see, it's like 150 milliamps. But it will still give you a bit of a boot. So the best way to do it is don't become part of the circuit and just connect it on there like I've just done. For example, I'll show you again. If you were to become part of the circuit, you'd have salty hands. You'd be holding this, and then you'd pick this up with the other hand. That's when you become part of the circuit. And you'll get frowny points for doing it, especially online. Righto, so what have we got here? Oh, we've got them connected up the wrong way. Hopefully someone picked that up too, but anyway. So we'll go drop that one. Cathode on. This one back up. That's getting a bit rough, that is, but anyway. Not going so well, is it? Give them a good squeeze together. And the way I double check it to make sure that the correct sides are connected up again is because obviously you want to make sure that the chlorine side or the anode side is the rusty side and the cathode side is non-rusty. And cathode is the black connection, the negative, and anode is the positive. It's a good way of keeping track of what's going on. Another way to do it is to go back and look at photographs. But you don't need me to tell you all this. I'm sure you can work this stuff out. And I just seen some leaking water coming from here somewhere, but I'd say it's coming out of that point there where it was in the cap. The same thing's happening to this one. So eventually after 3 days, or 2.5 days, 3 days, you must be forcing the fluid up and into the seal between the cap. So the cap's 2 layers, there's a top layer and there's a bottom layer. The fluid's getting caught in there and extruded out of the seal. And ending up everywhere, which means I've got to go and get this here, the green tray, and we'll put that under. Alright, so the green tray is under there now. It actually helps to elevate it a bit as well. One of my main concerns was when I first discovered that it was leaking was that it was because the whole system was on a lean and gravity was forcing it to come out this end. But as you can see there, that's definitely not the case. I suspect I could raise this up to half a foot even, and it would still be extruding fluid out of it. It's like an electro pump of sorts, which is a pretty interesting concept that I'm sure was discovered in the late 1800s or something like that. But anyway, I'm going to do a bit more research into it because I think it's a fascinating outcome that you discover when you do these things in your garden shed like I'm doing. Now I think that's going to actually do it for today's video. So the sun's going down there. Another couple of hours I'll be able to check out the progress of my solar distillation that's actually working. It's working remarkably well. But that's the update on regards to the electrolysis, and I guess for the time being we'll leave it and come back in a couple of days and have another look. That could be a cause for concern. You can see there, that's open voltage. Here we were thinking this video was over, not quite. So we're getting an incredible amount of resistance in this system. So that's working fine there. That's positive, negative to negative, and we're getting 13.6 volts from that battery system just over here. Makes perfect sense. But we'll connect it back up. I'll make sure it's a firm connection. We'll test it again. That's a better result. That's what we're chasing. So we've got a decent connection there now. And it is the one last thing you want to do before you walk away from your unit that's just been set up. Perfect. Well, not 13.33, that was a bit strange.